A telescope stationed a million miles from Earth just turned its eye toward a world so small and so far away that scientists genuinely did not expect it to reveal anything new. And yet it did. What came back should not have been possible with the technology we had just a few years ago. And it is already forcing researchers to rewrite what they thought they understood about the edge of our solar system. Before we get into exactly what was found, hit that subscribe button because this channel exists to break down real discoveries backed by actual published research, not recycled space myths. And there's a lot more coming out of the outer solar system that you will not want to miss. Let's get into it. For most of human history, Pluto was basically invisible to us. It sits roughly 4 billion miles from the sun on average, so distant that light itself takes more than 5 hours just to reach it. Even after its discovery in 1930 by a young astronomer working out of an observatory in Arizona, Pluto remained nothing more than a faint smudge through even the most powerful telescopes on the planet. For 75 years, nobody actually knew what it looked like. Nobody knew its true size. Nobody knew if it had weather, mountains, or an atmosphere at all. It was a dot on a photographic plate that scientists tracked and little else. Then in 2015, after a 9.5-year journey across the solar system, NASA's New Horizons spacecraft screamed past Pluto at over 30,000 miles per hour, capturing the only close-up images humanity has ever taken of this world. It had one shot, no orbit, no second pass, just a narrow window measured in minutes before it vanished into the darkness of the outer solar system forever. What that flyby revealed stunned scientists. Towering mountains made of solid water ice, a massive pale plain shaped like a heart, strange blue haze layers stacked hundreds of miles above the surface. But here is the part almost nobody talks about. New Horizons only saw a snapshot, a single frozen moment in time from one angle. It could not watch Pluto breathe, could not track how its atmosphere changed across seasons, and could not separate what was happening on Pluto itself from what was happening on its enormous neighboring moon sitting right next to it in the sky. For years afterward, planetary scientists were stuck. They had incredible photographs, but almost no way to actually study Pluto's ongoing behavior. That changed once the James Webb Space Telescope came online. Here is why Webb is fundamentally different from anything that came before it, including New Horizons. Webb does not fly past a target and take a picture. It sits at a stable point roughly 1 million miles from Earth and stares, using an enormous mirror and extraordinarily sensitive infrared detectors to break apart the faint light coming from distant objects into its individual wavelengths. That process, called spectroscopy, lets scientists read the actual chemistry and temperature of something without ever physically going there. In theory, this made Webb the perfect tool to finally study Pluto in detail. In practice, there was a problem nobody could get around. Pluto and its largest moon sit so close together in the sky, separated by roughly 12,000 miles, that from Webb's vantage point, across billions of miles of space, their heat signatures blur into a single blob. Every previous attempt to isolate Pluto's own thermal behavior from that of its neighbor had failed, not because the data was not there, but because there was no way to cleanly tell which world the heat was actually coming from. This is where the story gets interesting. Why? Because a team of scientists led by an astronomer at the Paris Observatory found a workaround. Instead of taking a single snapshot, they used Webb's mid-infrared instrument to track Pluto and its moon continuously as they rotated, measuring how their combined brightness rose and fell over time. Because Pluto and its moon rotate together in a locked orbital dance, always showing the same faces to each other, the researchers could mathematically separate the two heat signals using the subtle rhythm of that rotation. It was a technique nobody had successfully pulled off before, and it finally let scientists isolate Pluto's atmosphere from its moon's surface with total confidence for the very first time. And what they found did not match any model anyone had built. Back in 2017, a planetary scientist at UC Santa Cruz proposed an idea that most of his colleagues considered borderline absurd. He suggested that the hazy layer wrapped around Pluto was not simply sitting there passively. He argued it was actively absorbing sunlight during the day and then radiating that heat straight back into space fast enough to cool the entire atmosphere below what basic physics would otherwise predict. On most worlds, with a thick haze layer, like Saturn's moon Titan, the opposite happens. Haze traps heat like a blanket and warms the surface underneath it. The scientist was suggesting Pluto's haze did the reverse, acting less like a blanket and more like a radiator, constantly bleeding heat away from a world that already had almost none to spare. There was no way to test this directly until Webb's data came in nearly a decade later. When the numbers were finally crunched, they lined up almost exactly with what had been predicted years earlier. Pluto's upper atmosphere really is being cooled by its own haze, and it is running roughly 30 degrees Fahrenheit colder than standard models expected. Researchers are now describing this as an entirely new category of planetary climate, one that does not resemble anything else we have measured anywhere else in the solar system. Pluto is not simply cold because it sits so far from the sun. It appears to be actively refrigerating its own sky, using nothing but suspended particles drifting through an atmosphere thinner than anything on Earth. And this discovery reaches far beyond just Pluto. If haze can control a planet's temperature this dramatically, then Neptune's large moon, which has a strikingly similar nitrogen atmosphere, might be running on the exact same principle. Scientists are also now wondering whether Saturn's moon Titan, despite behaving the opposite way today, might reveal similar surprises once studied with this same technique. There is an even stranger implication buried in this finding. Before oxygen ever built up in Earth's atmosphere billions of years ago, our own planet may have been wrapped in a similar organic haze. If that haze behaved anything like the one just measured on Pluto, it could mean early Earth's climate was shaped by the exact same physical process, now confirmed nearly 4 billion miles away. Studying the coldest, most forgotten world in our solar system might be quietly teaching us something about the very beginning of our own planet's story. If you are enjoying learning about this the way I am telling it without the exaggeration and clickbait most channels rely on, drop a like right now because it genuinely helps this kind of research reach more people. Now let's talk about Pluto's giant companion moon, because Webb's new data uncovered something happening there too that scientists had suspected for years but had never been able to confirm directly. Pluto's atmosphere is constantly leaking. Methane and other light molecules drift upward through its extremely thin air, slip past its weak gravity, and escape into space permanently. This has been happening for billions of years. For a long time, researchers assumed that escaping gas simply dispersed into the emptiness of space and vanished. It turns out something has been quietly catching a portion of it the entire time. Pluto's companion moon, roughly the size of many countries here on Earth, orbits so close that the two worlds are locked in a shared gravitational embrace, spinning around a point in empty space between them rather than one simply circling the other. Because of the way this moon is tilted as it travels, its northern pole spends multiple decades in uninterrupted darkness. No sunlight reaches it at all for years at a time. That makes it one of the most efficient natural cold traps anywhere in the solar system. Methane molecules escaping from Pluto drift across that gap of space, unfreeze solid onto the moon's dark polar surface and sit there accumulating for years with nowhere else to go. Then, when sunlight finally does return to that region after decades of total darkness, something remarkable happens. Ultraviolet radiation and cosmic rays do not simply melt that frozen methane away. They break the molecules apart and force the fragments to reassemble into heavier, much more complex reddish compounds, permanently staining that region of the moon a deep rust color that stands out starkly against the otherwise plain water ice everywhere else on its surface. In effect, two worlds locked together in an ancient, silent exchange, one slowly bleeding its atmosphere into space while the other catches and repaints itself with the leftovers, a process that has apparently been running quietly since long before either world had a name. And the moon had another surprise, waiting inside Webb's data too. Researchers confirmed the presence of both carbon dioxide, the same gas you exhale with every breath, and hydrogen peroxide, the same chemical sometimes used to clean a cut, frozen directly onto that moon's surface. According to the published findings, the carbon dioxide most likely came from material buried beneath the surface that was exposed by ancient impact craters, while the hydrogen peroxide appears to have slowly formed after years of radiation, striking the moon's water ice and rearranging its molecular structure into something new entirely. This specific combination of frozen chemicals had never been confirmed there before, adding yet another layer of complexity to a moon that most people assume is just a plain, boring ball of ice. Now picture what it would actually feel like to stand on Pluto's surface, because the details genuinely do not match what most people imagine. The sun would still be visible, but only as an incredibly bright point of light, no bigger than a distant star, giving off almost no warmth and no real glare at all. You could stare directly at it without discomfort. The sky around it would sit in a permanent grayish-blue haze, never fully bright and never fully dark, just an unchanging dim glow stretching in every direction. The ground beneath your feet would not behave anything like ice does here. At nearly 400 degrees below zero Fahrenheit, water ice stops being slippery and instead behaves almost like solid rock, hard enough that striking it would produce something closer to a metallic ring than a crunch. The atmosphere, roughly 100,000 times thinner than what we breathe here on Earth, would offer nothing to survive on, though the extreme cold would reach exposed skin and freeze it almost instantly, long before suffocation ever became the immediate danger. And fixed permanently in one spot overhead, never rising or setting, that giant companion moon would hang motionless in the sky, a silent witness to a partnership that has been running for billions of years. Pluto's surface holds its own separate mysteries that Webb has only added new context to rather than fully solving. In one region, New Horizons photographed towering rows of jagged ice blades made of frozen methane, some reaching taller than a 15. Story building, arranged in long parallel ridges unlike anything ever documented anywhere else in the solar system. Elsewhere, two enormous isolated mountains rise out of the landscape with deep depressions at their summits and lumpy flanks that closely resemble cooled lava flows, except there is no molten rock anywhere on Pluto. If these features are what researchers suspect they are cryovolcanoes, structures that once erupted not with melted stone but with a thick slush of water, ammonia, and methane forced upward from somewhere deep beneath the icy crust. That internal warmth leads to one of the most debated ideas surrounding Pluto today, the possibility of a hidden liquid ocean buried roughly 100 miles beneath the surface, kept from freezing solid by the slow radioactive decay of elements inside Pluto's rocky core. The evidence for this is not a photograph. It is a pattern. Cracks and ridges across the surface line up in ways that match what scientists would expect from a subsurface layer of liquid water shifting slowly beneath a frozen shell. If that ocean genuinely exists, it has likely been sealed away from sunlight and radiation for billions of years, sitting under enormous pressure in total isolation, representing one of the strangest possible environments anywhere in the solar system for the basic conditions life requires. Right now, there's no mission plan to confirm any of this directly. No lander, no orbiter, nothing currently funded to send another spacecraft back to Pluto, largely because a return journey would take the better part of a decade. And outer solar system exploration rarely wins funding battles against missions closer to home that can deliver results in just a few years. It is worth pausing here to explain why a buried ocean on a world this small and this cold is such a big deal to planetary scientists, rather than just an interesting footnote. Similar hidden oceans are already strongly suspected beneath the icy shells of two of Jupiter's and Saturn's moons, both of which show far more obvious surface evidence, including active plumes of water vapor erupting directly into space in one case. Those two moons sit relatively close to their host planets, where gravitational squeezing from a nearby giant world provides an obvious source of internal heat. Pluto has no such neighbor. It orbits alone, far from anything large enough to squeeze it the way those moons get squeezed. If a small, unisolated world with no giant planet nearby to warm it can still be hiding a liquid ocean, powered by nothing more than the slow decay of radioactive material in its core, that would suggest buried oceans might be a far more common feature of icy worlds throughout the outer solar system than anyone previously assumed. Rather than a rare exception, limited to a handful of moons that happen to orbit close to a gas giant, it would mean the ingredients for these strange, sunless, sealed-away environments could be scattered across an enormous portion of the solar system that we have barely begun to examine. It also helps to understand just how difficult it was for scientists to even attempt this kind of measurement in the first place. Pluto is roughly 1,000 times fainter in reflected sunlight than anything Webb was originally designed to prioritize, and separating its heat signature from its moon required catching subtle brightness changes as small as a fraction of a percent over the course of each rotation. Earlier space telescopes simply did not have the sensitivity or the stability to detect a signal that faint and that precise from a target that far away. It took Webb's much larger mirror, its extremely stable orbit far from the heat and light interference of Earth, and years of careful instrument calibration before scientists felt confident enough in the data to publish it. That is part of why this result took until 2025 to arrive, even though Webb had already been operating for several years by that point. The team had to be certain they were not simply detecting noise or an artifact of the instrument itself, so they cross-checked the thermal light curves against multiple independent climate models of Pluto's atmosphere before concluding that haze truly was the dominant factor controlling the temperature. That level of caution is part of why planetary scientists are taking this finding so seriously, rather than treating it as a preliminary guess. There's also a quieter chemical story tied to all of this that rarely gets mentioned outside of academic papers. Even the extremely faint trickle of sunlight that reaches Pluto is still enough to break apart methane molecules high in its atmosphere. Those broken fragments do not simply disappear. They recombine into heavier compounds that eventually form reddish-brown organic particles, which slowly drift downward and settle onto the surface below over unimaginable stretches of time. This same basic family of molecules is thought by some researchers to be similar to material that may have once rained down onto early Earth, potentially contributing raw ingredients for the kind of chemistry that eventually led to life here. On Pluto, this same slow process has apparently been running for roughly 4 billion years, a continuous snowfall of organic material landing on a surface simply too frozen for any of it to ever spark into something alive. Watching that chemistry play out in real time, rather than relying only on indirect evidence billions of years old here on Earth, gives scientists something close to an active laboratory for studying the raw conditions that may have existed before life ever began anywhere at all. For now, Webb remains the only working tool we have, quietly checking back on Pluto every few months whenever it swings back into view, adding new pieces to a puzzle that keeps getting stranger rather than simpler. Here is the detail that tends to stick with people the longest after hearing all of this. Pluto is not special because of its size or its location. It sits inside the Kuiper Belt, an enormous ring of icy debris beyond the orbit of Neptune, home to hundreds of thousands of objects, and an estimated trillion or more comets, a region of space so vast it dwarfs the more familiar asteroid belt sitting between Mars and Jupiter by comparison. Only one spacecraft in human history has ever traveled deep enough into that region to closely photograph any of its larger residents, and it only managed close flybys of two objects out of the hundreds of thousands of similarly sized worlds believed to exist out there. If Pluto is genuinely cooling its own atmosphere using suspended haze particles, quietly feeding its companion moon with escaping gas, and possibly hiding a liquid ocean beneath a shell of solid ice, there is no real reason to assume it is the only object doing anything like this. It is simply the one close enough and bright enough for our current instruments to actually study in detail. Almost everything else, scattered across that same enormous region of space, remains almost entirely unobserved, waiting for a telescope, a mission, or a discovery that has not happened yet. Pluto was never really the dead end that a single vote stripping it of planet status in 2006 made it seem like. It turned out to be the beginning of an entirely new set of questions that scientists are still learning how to properly ask. And there's a very real chance that the next time Webb points back in its direction, the picture gets stranger still. If stories like this one, built on real published research rather than exaggerated headlines, are what you want more of, subscribe to this channel and turn on notifications, because there's a lot more waiting out there in the dark, and I will see you in the next one.